For this assignment, we selected East Asia Palm Production EAPP and their innovative bakery migrant PIC4D. PIC4D is made from the palm-based specialty fats, emulsifier and heat-sensitive enzyme such as amylase and lipase, and it's used to improve the softness and the shelf life of the bread and other bakery products. Its production involves fat melting and blending, emulsification, cooling, and crystallization, followed by low-temperature enzyme incorporation, which is the most critical step. Unlike traditional preservation, metachild scanning or freezing, PIC4D functions as an anti-skid scaling system, helping bread stay fresh longer without chemical preservation.
Next, I will explain the key chemical issue identified in PIC4D production. The main problem is temperature-induced enzyme denaturation. Both amylase and lipase in PIC4D are protein-based enzymes, which mean they are very sensitive to heat. During fat melting, mixing, or blending, high temperatures can cause this enzyme to unfold and lose their active site structure, resulting in loss of catalytic function. For amylase, its optimum activity is around 40 to 60 Celsius, but its activity drops drastically about 12% at 80 Celsius and becomes completely inactive at 90 Celsius. Lipase shows a similar sensitivity. Its stability decreases sharply as temperature rises, and its half-life becomes much shorter under heat stress. When these enzymes denature, they can no longer modify starch and lipid components effectively. This leads to faster starch retrogradation, inconsistent softness and moisture, accelerated scaling, and batch-to-batch variability. So overall, the key chemical issue is that poor temperature control during production directly reduces enzyme activity, which affects PIC4D's ability to deliver consistent functional performance in bread. For regulatory considerations, PIC4D must comply with the Food Act 1983 and the Malaysian Food Regulation 1985, which govern fat additive, processing aids, and labeling. Amylase and lipase are classified as processing aids, meaning they must come from approved microorganisms, be produced under GMP, and must not remain active in the final product. Codex Alimentarius also sets standards on purity, permitted additive, and safety validation. If temperature control fails and enzyme lose activity, this may lead to inaccurate shelf life claims, which could result in non-compliance with labeling requirements. For quality consideration, temperature-induced enzyme denaturation can cause batch inconsistency, reduce softness performance, and unreliable selling outcomes. Using a non-contact IR temperature monitoring systems helps maintain the correct incorporation temperature, supporting consistent enzyme functionality. This aligns with HACCP, where temperature can act as a critical control point, and with ISO 22000, which require validated control, measures, and documented monitoring. Overall, proper temperature control improves batch reliability and supports accurate shelf life labeling.
Now, let me begin with the chemistry behind the bread stallings. So the main cause of stalling is the starch retrogradations, where the amylopectin chains in gelatinized starch slowly recrystallize during the storage. So this process makes the breadcrumbs become more firmer, lose moisture, and feel dry. In fact, conventional bread can become up to 80% harder in just a few days. So this is why the East Asia palms formulate their PIC4D. So PIC4D formulations contains enzymes, also specialty fats that help to slow down this retrogradation process. So the enzymes break long starch chains into a shorter ones so they don't crystallize easily. So while the fats help retain moisture and keep the crumbs soft. However, the main problems during the PIC4D formulations is the enzyme temperature sensitivity. So during the productions of the PIC4D, the palm-based fats must be heated and mixed, but enzymes are heat-sensitive proteins that rely on specific three-dimensional structure. So if they are added when the fat mixture is still too hot, the enzymes can denature. So when denaturation happens, the proteins unfolds and the active site is lost and the enzymes can no longer break starch. So this means faster starch irrigations reduce the effectiveness of the PIC4D and the breads become hard much sooner. So temperature control is a critical chemical issue that is faced by the East Asia Palm Product Company. To solve these problems, our group proposed to using the infrared or the IR temperature monitoring. So these sensors are the non-contact real-time tools that can be installed directly on the margarine mixer during the PIC4D formulations. So they will be used to continuously detect the heat emitted from the mixture, which make them much more faster and more accurate compared to the normal thermometers. So with the IR monitoring, the enzyme can be added only when the temperature drops below the 40 degrees Celsius to prevent denaturations. So this also improve the performance of the microencapsulation system, stabilizer like the glycerol and sorbitol, and emulsifier that can help to maintain the bread softness. So overall, the IR supervisions ensure the stable enzyme activity and very consistent peak 40 functionality. So here it is simple illustrations of how the IR or the infrared sensor is mounted on the mixer. So the sensor continuously scans the surface temperatures and sends the data to the controller. So once the temperature is confirmed to be safe, the automated dosing pumps add the enzymes. So this approach reduces the human error, avoids hotspots, and ensure that every batch of the peak 40 is produced under thermally safe conditions. So in the long term, this reduces waste, improves the product quality, and helps Peak 4D maintain its anti-stalling effect.
Next, for the evaluation and continuous improvement plan for Peak 4D measuring, this section focuses on how each Asia pump product ensures the enzyme stability, quality consistency, and shelf life performance of Peak 4D using infrared temperature monitoring. To evaluate whether the IR monitoring system truly improved Peak 4D, we use four main assessment methods.
First thing first, we carry out the enzyme activity testing. This is done by using the DNS assay for amylase and pH state titration for lipase. By comparing enzyme activity before and after the process optimization, we can see whether the enzyme were protected from the heat. Higher retained enzyme activity means the IR system successfully prevent the thermal denaturation. Secondly, we conduct accelerated shelf life studies by storing bread at higher temperature between 35 and 45 degrees Celsius for 3 to 7 days. Here, we measure the crumb firmness, texture profile, moisture migration, and starch retrogression. When the bread stays softer for longer and retrogression slows down, it indicates improved anti-stalling performance. Third, we run real-time shelf life studies under normal storage condition. Bread is evaluated on days 0, 1, 3, 5, and 7, focusing on hardness, elasticity, moisture content, and crumb structure. If the bread made with Peak 4D remains soft and elastic for 5 to 7 days, it confirms the product is performing as intended. The fourth approach is internal IR process monitoring. The IR system continuously log the temperature inside the mixture, detect the hotspot, and record the exact timing of the enzyme dosing. This ensures enzymes are only added below 40 degrees Celsius. When this is controlled correctly, the enzyme activity is preserved and batch failures are significantly reduced.
Next, I will explain the continuous improvement strategies used to maintain the long-term consistency. The first strategy is data-driven quality control. Automated IR temperature logging combined with statistical process control chart help the factory track the temperature trends, detect the deviation early, and prevent enzyme deactivation. The second strategy is enzyme macroencapsulation stability testing. This monitors the thermal stability of the enzyme capsules and check whether the enzymes are released properly during baking. This to ensure the consistent anti-stalling performance of the Peak 4D product.
For the third strategy is implementing online NIR spectroscopy. This allows real-time monitoring of water content, fat crystallization, and emulsion uniformity inside the margarine. With NIR, the production team can make immediate adjustment without waiting for the lab test. Another important aspect is staff training and also updated SOPs. The operators and QC personnel need proper training on temperature control, enzyme addition timing, and responding to IR alarms. Updated standard operating procedures ensures everyone follow the correct workflow and complies with the food safety standard like HACCP and also ISO 22000. Lastly, regular equipment maintenance and calibration are essential. IR sensors, the NIR probes, the cooling jackets, and mixer must operate accurately to maintain proper temperature control. Well-maintained equipment help to prevent deviation that could damage the enzyme activity or affect the quality product. In conclusion, these evaluation methods and continuous improvement strategy help to protect the enzyme activity, improve the bread shelf life, reduce batch failures, and also to ensure the consistent peak for the quality in bakery application.
To conclude, temperature control is vital when adding enzyme in Pig 4D to extend brief shelf life. Without proper temperature management, amylase and lipase lose activity, leading to inconsistent crumb, softness, and brief variation. By using infrared monitoring, we can maintain safe temperature, protect enzyme function, and support HACCP compliance. This ensures smooth processing, stable quality, and help Pig 4D meet both industry standard and consumer expectation.